Today, we have all become aware that the earth is fragile. I think in this century, the most inspiring element for architecture will be the fragility of earth. It's not about morality, it's about necessity. Renzo Piano. In an age of rising carbon emissions and pollution, society has begun to implement changes in architectural practices in order to counter these negative trends. This movement has universally been coined as sustainability. These same principles carry over into the language of architecture and have manifested themselves in the form of material recycling, green area preservation, topographical integration, renewable energy, and energy efficiency. A contemporary paragon of this modern style can be seen in the 2008 reconstruction of the California Academy of Sciences designed by Renzo Piano. As the largest recipient of the Platinum LEED certification to date, according to Joe Mabel, the new California Academy of Sciences building is the complete representation of the tenets of modern sustainable architecture, best exemplifying both its praises and criticism. According to Mass Design Group, the Academy was founded in San Francisco in 1853. The institution was conceived with the simple goal of surveying the new state of California and unifying rare and rich natural museums. 2 decades later, it adopted its current name and began conducting research while operating as a museum to educate visitors about the natural world. The museum rapidly gained popularity. However, the lack of cohesion between the new facilities hindered advancements in the Academy's research programs and museum activities. By the 1990s, the attendance was dropping by about 4%, and the Academy was seeing distressing numbers. The Academy's last straw came in the form of the 1989 Loma Prieta earthquake, which demolished the aquarium and rendered the Academy's other facilities unusable. Soon after, the museum decided to host a competition for a redesign of the Academy. With this new design, the Academy hoped to conduct a complete reconstruction that unified all of the Academy's facilities. The goals of the new Academy were to create an environmental sustainable building that would serve as an attraction for visitors and educate new generations about contemporary global issues. The competition ultimately presented them with the Italian architect Renzo Piano. According to Renzo Piano, the concept stemmed from the idea of a roof that resembled a piece of the park flying, and to utilize natural light and transparency to facilitate awareness of one's presence within the Golden Gate Park. His vision was faithfully realized, as Joe Mabel notes, the use of high, transparent, low-ion glass to cover most of the exterior. 2 90-foot diameter domes would dominate the longitudinal axis of the museum, one housing the rainforest and the other the planetarium. And the aquarium would bring visitors beneath the ground. According to Mass Design Group, a nonlinear circulatory design was adapted in hopes of encouraging visitors to engage with the museum's interactive educational materials. The design team took every possible measure in their pursuit of sustainability. In the construction, 90% of the demolition waste from the old building was used. The steel structure of the museum was made entirely of recycled steel. As the centerpiece which dictates the rest of the design, the living roof is arguably the museum's most impressive feature. The 2.5-acre roof provides insulation and captures nearly all water runoff from the structure. Its skylights open and close to provide natural ventilation. This, in conjunction with the glass walls, allows for 90% of the busy space in the museum to be lit by natural sunlight. The edges of the roof are lined with photovoltaic cells, which provide 5 to 10% of the building's power usage. To reinforce the idea of a living roof, it is home to about 1.7 million local plants and becomes a sort of extension of the natural habitat. Naturally, it changes color throughout the seasons. In conjunction with these more apparent features of sustainability, the building's interior technologies allow the museum to consume up to 35% less energy than stimulated by California's rigorous building codes. According to Emeritus Professor of Architecture Brian Williams, The high visibility of these design features resonate with the idea that this building is meant to educate.
However magnificent the academy structure may be, the process was not as glamorous as the end result. According to Mass Design Group, the design of such a colossal and comprehensive project required the collaboration of several groups, including architecture firms, an R&D team, exhibit design firms, and many more. In order to address the difficulty of managing such an expansive team, the Academy hired Don Young and Associates to facilitate a centralized communication system which limited direct contact between the different teams and caused lapse in coordination. Some exhibit designers expressed concerns over the Academy's emphasis on piano's living roof and how it compromised their designs. Another of the project's issues can be seen in the last-minute changes during construction as a result of missing components in the architect's plan. A point of controversy is the cost that often comes with sustainable architecture. Evidently, according to Mass Design Group, the original budget of the museum exceeded that of the 2005 reconstructions of both the De Young Museum and the Monterey Bay Aquarium, totaling to $388 million. In the end, this projection saw a 25% inflation, up to $488 million. These budget increases can be attributed to the custom glass and metal structures, as well as rearrangement of typical building phases. Another possible source of expense is the research and development involved with the building. According to Brian Edwards, the CAS features an unprecedented building profile and ventilation arrangements, which necessitated extensive pre-construction modeling, which included smoke tests and wind tunnel testing. Incidentally, one of the main proposed advantages of sustainable architecture is that of life cycle costs, which means these buildings should theoretically make up for their cost with low operating budgets. Yet, Mass Design Group has indicated that these budget increases have not only put the Academy in debt, but rising operation and facility costs have made it difficult to pay off said debt. The word sustainable is defined as relating to or being a method of harvesting or using a resource so that the resource is not depleted or permanently damaged. Hence, sustainable architecture is the kind of architecture that aims to satisfy the needs of the people and the aesthetic beauty of a building without putting our future needs of resources at risk. For an architect, the environment can either be an ally or an enemy. Utilizing the environment to push forward and enhance design rather than present obstacles to its execution is the core principle of sustainable architecture. Renzo Piano seems to have mastered this skill through the design of the California Academy of Sciences, but there are some issues with the concept and implementations of these designs. Sustainability's heavy reliance on expensive technology is something that has been criticized in projects of the same nature, and the construction of the Academy is no different. The use of materials such as thermal glass or custom-made glass tend to raise material and construction costs, which seems to increase exponentially in sustainable designs. The balance between the use of technology and how it is integrated into the design is arguably the main flaw with sustainable architecture. The paradoxical nature of energy saving and inefficient energy usage is also something to consider. Adding active energy systems results in reduction in the energy used and hence reduces the overall cost. But due to the reduced cost, people will start using the energy less carefully, causing the consumption to increase, thus canceling out the initial saving in cost and energy. This phenomenon is known as the Jevons paradox and is something to consider when it comes to the validity of sustainable building. Examining the structure and energy usage of the California Academy of Science contributes to a more significant discussion of sustainability. Has this become a worthwhile practice, or is it a theory yet to come to fruition? As evident in the high costs of seemingly sustainable materials, the technology necessary for net zero or energy-efficient architecture has not yet been developed thoroughly enough to truly be defined as sustainable. Further compounding the costs of sustainable materials is their high-maintenance nature and the volume of tests required to be LEED certified. Critiques of sustainable architecture also point to small alterations in any specification in terms of materials greatly diminishing eco-friendly results for the overall project. This is exemplified by the Academy and that the final construction was over budget due to incredibly precise, intricate specifications. Extensive further research is crucial to the success of this architectural practice. Regardless of the high costs and continual development in the practice of sustainable architecture, it can still be revered in its attention to the seemingly proliferating contingencies of environmentally conscious design. Renzo Piano's design is successful in the sense that it clearly conveys its intended purpose. The California Academy of Sciences merges seamlessly with the environment around it, perfectly exemplifying the core principles of sustainable architecture.